Hi there, this is Coach Eikrem. Welcome to our third video on moles. The topic of this video is going to be percent composition, which is very straightforward and hopefully really logical. There's only a few slides on this, so we will make this as quick and painless as possible. Percent composition is the percent by mass of each element in a compound. So if you want to look at it with a formula, percent composition equals the mass of the element that you're finding the percent composition for over the molar mass of the entire compound. And it's really important that you understand that concept. So go ahead and add this to the formula if you've already written it down. It's the mass of the element over the molar mass of the entire compound. And then, of course, to make it a percent, you times by 100. You can find the percent composition if you have either the chemical formula or if you've got the masses of all of the elements in a sample. So let's go ahead and do one. It says calculate the molar mass of the compound, and we're actually going to calculate and this percent comp. Because I shortened these slides, so it's a little bit off. So we're going to calculate the percent composition of magnesium chloride. So magnesium chloride, we know that to be MgCl2. So if we're going to plug this into our formula for percent composition, we need to know the molar mass of the compound and the molar mass of each of the elements that is in this compound. So we're going to start with magnesium. There's one magnesium, and if you look on your periodic table, the molar mass of magnesium is 24.3. So when you work that out, the molar mass of magnesium total is 24.3. And I'm actually going to make it, there we go. Chlorine, there's two of them in our compound, so 2 times the molar mass of chlorine, which is 35.45. And when you work that out, you get 70.9. When I add these up to find the molar mass of my entire compound, you get 95.2 grams per mole of magnesium chloride. Now we have everything we need to calculate the percent composition, and you want, whenever you're calculating percent composition, unless it specifies, you're calculating it for every element in that compound. So you're going to have to do an equation for each individual element. So let's start with magnesium. So to find the percent composition, so I'm going to put percent of magnesium. We know it to be the mass of the element over the molar mass of the entire compound. So in this case, the mass of magnesium is 24.30. And the mass of the entire compound is 95.2. And of course, you times it by 100. And when you work that out, you get 25.5% magnesium. And it's important to note, it doesn't matter how large your sample size of magnesium chloride is. You can have 10 grams of magnesium chloride, 15 grams, 100 grams, 1,000 grams. If you've got a sample of magnesium chloride, 25.5% of it will be magnesium by mass. Remember, this is all by mass. And then percent chlorine is going to be part over the whole, so to speak. So it's the molar mass of the chlorine, which is 70.9, over the molar mass of the entire compound, which is 95.2. Times it by 100, and you get 74.5% chlorine. And the same concept applies here. It doesn't matter how large your sample size is, 74.5% of magnesium chloride will be the chlorine. And you can check your work here by adding these 2% up, and they should equal 100% because these are the only 2 elements in magnesium chloride. So, pretty easy. Let's move on. This one says, find the percent composition of each element in aluminum sulfide, and I'm going to correct another error here. Let's just make this aluminum sulfate because we want to do one that's a little bit trickier, and aluminum chloride is a little easy. So let's do one that's a little bit harder. Bit of a challenge here. Aluminum sulfate using your nomenclature, you know to be Al2SO43. So remember, the first step in determining our percent composition is making sure we know the total mass as well as the mass of each of the elements in our compound. So let's start with aluminum. There are 2 aluminums here, and the molar mass of aluminum is 26.98. And when we calculate that out, you get 53.96. For sulfur, there's 3 of them. Remember, there's 1 inside the sulfate, but then there's 3 of them, so that distributes 3 times the molar mass of sulfur, which is 32.06. And that works out 3 times 32.06 to 96.18. Remember, these are all grams per mole. This is the molar mass of the element in the compound, and the amount. It also takes into account the amount and how many of them you have, so just kind of keep that in mind. And then oxygen, we have 12 of them because there's 4 inside the sulfate and then 3 here, times 16. And you get 192.00. Add that up to get our total, and we get 342.14 grams per mole. That is the molar mass of the entire compound of aluminum sulfate. Now that we know all that, we can work out our individual percent compositions. So let's start again with aluminum and keep it in order. So the percent of aluminum is going to be equal to the part over the whole, or the mass of aluminum over the mass of the whole compound, so 53.96 over 342.14. It's important to note you are not using this number when you put that in there. Remember, that's the molar mass of 1 aluminum, but remember, you've got 2 in here, so you always have to take into account how many you have in this particular compound. So these right here are the numbers that you're using. Times this by 100 down here, and you end up with let me find my work, sorry. 15.8%, roughly. And then we've got percent sulfur. Same concept. Now, got that from right here. Over 342.14 times 100 to make it a percent. Don't forget the times 100. You'll get a decimal. 28.11%. This is aluminum, and this is sulfur. Make sure you notate which element you're dealing with in each piece, just because it makes it clear and it makes it easier. And I'm going to actually box each answer to set a good example here. And then we have oxygen. I'm going to go ahead and do that one up here. Percent oxygen is going to be equal to 192.00 over 342.14 times 100. When you work that out, you should get 56.12%. That's a 1-2, apologies on that. All right, so when you look at this, you can check your answer by adding it up and making sure it adds up to 100, but you can also look and see if it's sensible. When you look at how many of each element you have and its molar mass, or its mass, within the compound, yes, oxygen has the least amount of molar mass, but there's 12 of them, so it makes sense that it has a percent of 56.12% inside that compound. If you ended up with something like 5.6%, and you kind of are looking back to check your work, you should realize there's no way that if there's 12 oxygens at that molecular weight, that it would equal anything less than about 50% of that compound. So always kind of check back and just, it's not an exact, but at least will give you an idea if you're on the right track and if you, probably did it correct. And then, of course, add them to 100 and make sure that everything's accounted for. And if you have a discrepancy, go back and check your work. All right, using the percent composition from the questions above, how many grams of aluminum are in a 250 gram sample of aluminum sulfate? So we're assuming we know that the percent of aluminum in aluminum sulfate is 15.8%. We're saying we know that already from the previous problem, which we already worked out. So we're saying if we've got 250 grams of aluminum sulfate in our lab or what have you, how many grams of aluminum do we have? And if you know that 15.8% of any size sample of aluminum sulfate will be aluminum, this is pretty easy and straightforward to work out. So you know that you've got 250 grams of aluminum sulfate. And you're going to just multiply that by the percent of it that's aluminum, in the same way that if I told you, you have 100 kids and 25% of them were going to the basketball game, you would take 0.25 times 100 and end up with 25 kids. Same concept, just different numbers. So 250 grams times the percent of aluminum. Remember, you cannot leave it in percent form in order to do math with it, so you're going to convert it out to a decimal of 0.158. And when you work that out, 39.5 grams of aluminum. And you can do this for any size sample with any element as long as you know the percent composition of each of the elements in that particular sample. All right, I hope this made sense. Hope you took good notes. Write down any questions you have, and we will talk about them in class tomorrow. Thanks, y'all. Have a good night.